Hello. This video demonstration will show how to use the eye constraint behavior in the new skeleton utilities. This example rig is included in the Spine Unity runtime. It consists of 4 parts: a foreground that covers the eyes and gives a good mask for the motion of the pupils and the inside of the eye, a background which is just the eye whites, and 2 independent eyes that are each parented to their own bone so they can be controlled directly by the skeleton utility. After exporting this and importing into Unity, you should get a skeleton data asset, and if you right click on that and choose spawn, you should get something ready to go inside of the scene graph. By selecting that object, you should have a add skeleton utility button in your inspector. Just click that to add the inspector and choose spawn hierarchy, and in this case we can choose follow, which will spawn all of the bones in follow mode attached to this skeleton. I'm going to select the 2 eye bones, Li and Ri, and change them from follow to override mode so that we can now move the bones independently inside of spine. The next thing I'm going to do is select the root bone, and I'm going to drill down into the Spine Unity folder under Skeleton Utility and add the Skeleton Utility eye constraint to the root bone. It takes a few parameters, but most importantly is the eyes array. You must add every eye that you want controlled by the skeleton utility eye constraint to this list. So I'm going to add both the left and the right eye, and we are actually ready to start testing things. So I'm just going to hit the play button. And now I can move the target position of the eye constraint up or down, left or right, and it does a pretty good job of controlling the eye's look position. But with most vision controllers, sometimes you want more than just a point, you actually want an object in the scene graph. So I'm going to create an empty game object, and I'm going to call it eye target, and I'm going to give it a icon so that we can easily see it inside the scene graph at all times. Reselecting the root, I'm going to drag the eye target onto the target field of the eye constraint behavior. Now when we play, the eyes should automatically look at that target. This does behave correctly with position and rotation with the entire skeleton root. So if you are playing an animation on a face and it happens to rotate the head back and forth, there won't be any tracking problems. It'll always be functioning in world space. And that pretty much covers all of the basics. In addition to the basic setup, there are also some parameters like the radius, which determines how far the eyes move from their origin position. So if you drag this up, the eyes will be able to move further. You do have to be careful when you make rigs like this that they don't break out of the mask that you've created for them. But that's entirely up to you as a creative person. The other really cool parameter is the speed parameter that controls how fast the eyes can go from one position to another. So if you turn that way down, you can have a very smooth eye transition. This actually looks kind of creepy now that I look at it. But again, that's entirely up to you. The next thing I'm going to show is a more advanced eye rig. And it will control each eye independently, which allows you to do some more fine-tuned animation. So if you wanted the character to go cross-eyed, you would need to have a rig more similar to this. I'm going to keep the eye target around, but I'm going to rename it eye targets because we will have more than one target. And I'm going to reset its position so that it's dead center between the two eyes. Going back to the root, I'm going to remove the right eye from the eyes array because this was going to be the left eye tracker only. Underneath eye targets, I'm going to create a child game object, and I'm going to call it left, and move it roughly to the position of the left eye. Similarly, I'm going to duplicate that, call it the right eye, and then flip it to the other side. And again, move that roughly to the position of the center of the right eye bone. Under the eye constraint behavior, I'm now going to change the target to the left eye so that we're only tracking that particular eye to that particular target. And I'm going to copy the eye constraint behavior and paste it onto the same object as a new behavior and change out all the parameters to the right eye. So when we hit play, our behavior here should be pretty much the same as with the single target. The exception is that now I could take this center object and I could scale it out or in to create a very easy cross-eyed effect. As with all good things, there's usually a downside. The downside to this is if you rotate the face or the animation playing on the head that you may have is rotating, that they will not stay aligned with the eye target, so you must also rotate the eye targets with it. Just to show what happens here, if the character's looking up and the eyes rotate, we won't be in line all the time. You can get some very weird looking effects because the left eye target is over here and the right eye target is over here, so they're still working correctly, but not visually correctly. So you would need to also rotate the eye targets to match the orientation of the face, or at least the parent bone of the two eye bone transforms. Okay, that pretty much sums it up. There is an example in the Spine Unity runtime for the basic eye rig, so please take a look at that and have fun. See ya.